Now we'll discuss the relational algebra. So, what is a relational algebra? So, what are the operations that are performed on relational algebra? We'll go for what is a relational algebra. A relational algebra is a non-procedural, so it's a procedural language. It is a procedure language which receives input as a as instance of a relation and produce the occurrences of the relation as output. Of a relation as an output. What is relational algebra? A relational algebra is a mathematical algebra which receives input as instances of a relation. Instances means records, which receives input as a relation, which receives instances of a relation as a relation and produce the occurrences of the relation as output. Such an algebra is called as relational algebra. It's one mathematical algebra which perform operations on relation. So in other words, we say that it is a algebra which receives, which performs operations on relations. It is a mathematical algebra which performs operations on relations. The operations that are performed on relation is first one, selection, projection, rename, union, intersection, difference, join, division. These are the operations that are performed on relations. So one is selection, projection, rename, union, intersection, difference, join, and division. These are the operations that are performed on relational algebra. First, we will discuss what is selection. So before going to selection, we take some inputs and produce output. So selection, I will take one input. Employee number, employee name, salary, department. Employee number, employee name, salary, department. For example, 101, 5. For example, this is the table. First, we go for selection. What is selection? Selection. A selection is a horizontal subset of a relation. Is a selection is a horizontal subset of a relation. Yeah. The horizontal subset of a relation is we call as horizontal. So, in order to select some of the rows from a relation, we use selection. Selection is used to select some of the rows based on the condition. We use selection. A selection can be represented by mathematically represented by selection is mathematically represented by the symbol. This is the, so we use the symbol. So actually I'll take the copy. This is the mathematical representation of the selection. So mathematically sigma, we call it sigma, that is the sigma. So the syntax of selection is, so sigma, so we use the sigma, then we write the condition, sigma, then condition, after that table. Relation. So sigma. This is a subset. Second, then we do the relation. This is the syntax of so this is the syntax of selection. Sigma. This is the horizontal, this is the process sigma. So first we'll use sigma. Sigma, then condition, we write the condition, and the name of the relation at the relation. Table name is in the relation. This is the syntax. For example, list the details of the employees who were working in CSC department. Suppose I want the details of the employees who are working in CSC department. So CSC department లో వర్క్ చేస్తున్న వాళ్ళ యొక్క డీటెయిల్స్ కావాలి అన్నాడు. సో నాకు ఎంప్లాయీస్ ఉన్నారు, దాంట్లో సిఎస్సి డిపార్ట్మెంట్లో వర్క్ చేస్తున్న వాళ్ళ డీటెయిల్స్ కావాలి అన్నారు. సో అప్పుడు మనం యాక్చువల్గా సో ఏ విధంగా చెప్పాల్సి వస్తుంది? సో వి యూజ్ ద సిగ్మా. ఫస్ట్ వి యూజ్ ద సిగ్మా, దెన్ condition. So what is the condition? Department equal to what? CSC. So this is the subscript. Department equal to CSC. Then what is the relation? So we make so our relation is what is the relation? Employee. So then the output is the output. What is the output? So who are working in CSC department? There are two rows working CSC department, 101 and 102. This is the output. So this is the output. So we have two employees. So 101 Ravi is one employee, and another is working at Sai Dalgar. Suppose we will go for another example. List the details of the employees who are working, whose salary is greater than 6,000. Whose salary is greater than 6,000. Suppose I want the details of the employees whose salary is greater than 6,000. 6,000 కంటే ఎక్కువ ఉన్న వాళ్ళ డీటెయిల్స్ నాకు కావాలి. Whose salary is greater than 6,000. So then what we can do? So first which is selection. Selection. So what is this? Salary greater than 6,000 from which table? Employee. This is a subscript. The condition must be a subscript. So then this is the condition. So in the relation whose salary is greater than 6,000, this is the row we are getting. The final output is this the output. This is the output. So 102 whose salary. Similarly, list the details of the employees whose salary is less than 5,000. So less than 5,000 salary ఉన్న వాళ్ళ యొక్క డీటెయిల్స్ కావాలి. So less than 5,000 whose salary is less than 5,000. So then what we can selection. So this is the process. We go for selection. Selection. So what then condition? Sigma. Then condition what is salary is less than whose salary is less than 5,000. 5,000 from which table? Employee. So this is the way. So this is the way we are getting the details. So this is called a selection. A selection is a horizontal subset of a relation. That means to select the rows for some of the rows which satisfies the condition. So that for that purpose we use the selection. So a selection is a horizontal subset of a relation. A selection can mathematically represent by a sigma. So we'll represent mathematically by sigma, small letter sigma. The syntax, what is the syntax? Selection sigma, then condition. Of that we must write the relation name. For example, we have the table employee table is there. Suppose I want to select the details. So employee, this is the process. Suppose I want to select so names of the employees who are working in CSC department. Suppose I want the details of the employees who are working in CSC department. So then we'll write sigma department equal to CSC employees. So we'll get the details. Suppose I want the salary whose salary is greater than 6,000. Yes, we get the entire row. So we'll get the entire. In the case of selection, we can get the entire row. Next, we go for projection. Projection. It is a vertical subset of a relation. It is a vertical subset of a relation. Selection is a horizontal, so it is a vertical subset of a relation. So it is represented by pi. Pi symbol what? We use pi symbol for so we use pi. We use symbol pi. So we'll go for a symbol. Need to copy the symbol instead of searching the process. We need to copy from somewhere else. Pi. By using pi symbol, so we use we are represent the symbol pi. The syntax. The syntax of projection is how to represent what is the syntax for projection. What the syntax for projection is so pi, then column names, column lists, then we go for relation. Pi, column lists, relation. This is the for this vertical subset we call this pi, column list, and relation. This is the vertical subset of the relation. For example, list names of all the employees. List the names of all the employees. Suppose I want the names of all the employees. So suppose I want our names of all the employees, then we go for projection symbol. So what we need names. So name. So with table employee. So then we get the names of all the employees whose salary is the way. Name from employee. So name is the subset. So we get the details of all the employees. So then what is the output? So what is the output? What is the output? So what is that? These are the names. So we get this is the output. This is the output. We have the output. What are the names of the employees? We have these are the Ravi, Nesai, these are the details. Suppose similarly, list the names and salary of all the employees. Suppose I want name and salary of all the employees. I want name as well as salary of all the employees. I want name, so as well as salary. So this is called as what we need name, comma salary, name and salary of all what employees. So then what we get the name and salary of the employees. This is the name and this is the salary. So we are getting the name and the salary. But this now. So we are getting the name and salary. So this is the way. So this is the horizontal. So we are getting the entire or the vertical subset of the relation. Selection is horizontal subset. Sometimes it is possible to combine both the vertical as well as horizontal. So depends on the condition we can write it. So for example, is name and salary of employees who were working in CSC department. Suppose I want the name and salary of employees who are working in CSC department. Actually, we are getting the entire details by using selection. So from that again it is necessary to projection. So we use both the symbols, projection as well as selection and projection. Name and salary. So we need name and salary. So name and salary of employees. So again we need sigma. We need sigma who are working in department, CSC department. So this is the output. So what we get? First we'll select the rows. So first we make it as one bracket. Then it will be very good. From selection, we can select the details of the employees who are working CSA department. From that, we are selecting the selection. This is the way. So then we are getting what is the output? We are getting the only we are getting employee name and salary of this is the output. So name and salary of the employees who are working in CSC department. These two persons are working in CSC department. So like this we can select the rows. So this is the way we can use selection and projection. Selection is a horizontal subset of a relation. Projection is a vertical subset of a relation. So sometimes it is in query we can use selection and selection and the projection. So to get the specific column and the specific rows. So to get the specific columns and to get the specific rows, we use both selections as well as projections. When we use selection and projection, we get the specific rows and the columns. This is the way we are using. Similarly, This is the way to get the details. Again, we go for a rename. This operation is used to rename a relation, to rename a column or relation. So to rename a column or to rename a relation, this is attributes of a relation. The attributes of a relation, it is represented by, so that symbol we called as this is the symbol we are using. So this is the rename. Just we want to rename an attribute. So for example, rename A by B. So here an attribute B is renamed by A. This is the way. So just we use the rename. Suppose we want to change the name of the attribute, we use rename. So this is the way we are using. So these are the unary operations. So these three are called as unary operations. So unary. So next we go for union. So an union will contain the rows of the first table or second table or both. This operation will contain the rows of first table or second table or both. Contains the rows of all the two tables must be same number of columns and domains. So in order to union, suppose we want to perform union, so this we use the union operation. So to perform union and inter-union, intersection and difference, the two tables must be union compatibility. We called as this is called as union compatibility. Union compatibility means there must be an equal number of columns in both the tables. So if the first table has 3 columns, the second table must also contains 3 columns. So the two tables must be union compatible. So when the two tables are union compatible, then only we get the final value. So for example, there are two tables, table 1 and table 2. Suppose we want to perform union of these two, for example. Pronym, for example. Table T1, table T1, for example. So this is the employee one of one. Suppose this is one table. Suppose we have another table also. Table T2. Employee number, employee name, salary. So this is 101 Ravi, 301. For example, there are two tables, table T1 and table T2. Table T1 has 4 rows and 3 columns. Table T2 has 3 rows and 3 columns. So to perform union of these two, the two tables must be union compatible. So otherwise we cannot perform union in set operations, union in intersection difference. So the union compatibility means there must be an equal number of there must be an equal number of there must be an equal number of columns in both the tables. T1 and T2 has same number of columns. So it is represented by the symbol. So for example T1 union. So we use the union symbol. T1 union T2. So T1 union T2. When you use the T1 and union T2, so the resultant table is so this is the resultant table. So whenever we are performing union of two tables, the two tables the result will contains the elements which belongs to either first set or second set or both. So the element there are the first table values are 4 and the second table values are 3. One is which is common, so we can remove the common element. That means 101 you can remove. So then we get the finally we get this. This is the way. So this is the way we are getting a union of two tables. Then again we go for intersection. What is an intersection? An intersection of two tables will contains the rows which is common under both the tables. The rows which are common in both the tables. The intersection of two tables will contain the rows which are common in both the tables. So it is the syntax is represented by intersection symbol. We go for intersection symbol. Union, difference, and this is the intersection. This is represented by intersections. Example, T1 intersection T2. T1 intersection T2. So when T1 intersection T2, the result will contains the rows which is common under both the sets. Which row is common under both the sets? Only 101 is the common under both the sets. The result will contains this row. This is the result, intersection. So while in case of intersection, it contains the rows which is common under both the sets. So what are the rows which is common under both the sets? 101 is the common under both the sets, and finally the result will come. This is the result. Then difference. Then we go for difference. So what is the difference? The difference of two tables will contain the rows which is in first set but not in second table. The difference of two tables will contain the rows which is in first table but not in second table. So it is represented by minus. So we use the minus. For example, T1 minus T2. So T1 minus T2. So when you use the T1 minus T2, so it contains the rows which is in T1 but not in T2. So we have the rows. So this row is deleted because so it is also contains. So 101 is deleted because 101 will appears both T1 and T2. So it contains the rows which is in first table but not in second table. Only the first table it contains 101, 102, 102, 202. Second table is 101 is again appears. So we removed the 101. Yes. So this is the way. So suppose we go for another example, T2 minus T1. When you write T2 minus T1, so it contains the rows which is in second table but not in first table. So this is the output we get. However, this row is deleted because this row is appears in second table also. So like this we can perform the different set operations. These are the different set operations. So these are some relational algebra operations. What is relational algebra and what are the relational algebra operations? What is relational algebra? What is relational algebra? What are the operations that are performed on relational algebra? So what is relational algebra? Relational algebra is a mathematical process which receives input as a instances of a relation and produce the occurrence of the relations. So as an output. So that means it receives input as a instances means records. So there are different operations that are performed on relational algebra: selection, projection, rename, union, intersection, difference, join, and divisions. These are the different operations that are performed on relational algebra. So what is a union? Selection. A selection is a horizontal subset of a relation. Suppose we want to select only specific rows. from a relation, want to select specific rows of a relation, we use selection. Selection will be represented by sigma. Similarly, projection. Projection is used to select specific columns of a relation. So to select specific columns of a relation, we use the projection. Projection is represented by pi. So by using pi, we represent the projection. Sometimes it is possible to combine both the selection and procedures, because I want to only selected rows and selected columns. So to make selected rows and selected columns, we use selection as well as projections. So rename. Rename is used. So rename is used. Rename is used to rename the attribute. The attribute with another attribute is the rename. Similarly, we have the set operations, union, intersection, and difference. What is union? An union of two tables will contain the rows of the first table or second table or both. To perform union or intersection or difference, the two tables must be union compatible. What is union compatibility? So union compatibility means there must be an equal number of columns in both the tables. For example, we have the two tables T1 and T2. So whenever we are performing union of these two tables, so we'll get the rows which is in first table, second table, and both. So intersection is the which is common under both the sets. Intersection. Difference is the elements which belongs to the first set but not in second set. So like this, we are performing the relational algebra operations. These are the some relational algebra operations. Okay, we'll discuss next class. Tomorrow is all day. Again, we'll meet on Monday. Okay.